the aim of this video is to give you a step-by-step method that you can follow in order to find left-tail critical regions. So we've got a random variable x which is binomially distributed with 20 trials, and p is the probability of success on each trial. So the null hypothesis is that p is equal to a third, and we think that the probability is actually less than a third. So that's our alternative hypothesis. Now this is called a left tail critical region because it's got p is less than a third. So whenever you see p is less than, you're going to follow this method for a left tail critical region. So the first step for finding the critical region is to, and this will almost always be your first mark, is to say if h0 is true, what distribution does x follow? So x would be binomially distributed with 20 trials, and the probability of success would be a third if h0 is true. So you just need to write down what's the put that probability from h0 in there. Your next step is actually to use a bit of trial and error to find out what the critical region is. So because it's a left tail critical region, let's start off by finding out what the probability of x equals 0 is, and you can always start off by doing this for a left tail critical region. So if you go on distribution, binomial, cumulative, and you put x is 0, that will give you the probability of x being less than or equal to 0, which is just the same as the probability of x being 0. Number of trials is 20, and for p, we're going to put the h0p in, which is a third. So that probability is 0.04%. So next we're going to do the probability of x being less than or equal to 1. So we just need to go on cumulative binomial again and just change x to 1, and that'll give us the probability of x being less than or equal to 1. And that's 0.3%. So we need to look at this significance level. In this question, it's a 5% significance level. So what we need to do is we need to keep going, following this pattern, until we get a probability which is more than 5%. So next, let's do the probability of x being less than or equal to 2. So we'll just change x to 2 on cumulative distribution to get the probability of x being less than or equal to 2. So that's 1.8%. So we need to keep going because we haven't found a probability that's more than 5% yet. So the probability of x being less than or equal to 3 is 6.0%. So what we're aiming for is we're aiming to find the probability in this list which is as close to 5% as possible, but not more than 5%. So this is what we're looking at here. This is the probability which is as close to 5%, but not more than 5%. So this gives us our critical region. Our critical region is going to be x is less than or equal to 2. And it's important to realise that it's not p x is less than or equal to 2, it's just x is less than or equal to 2. In part B, we're told that actually we saw x is equal to 3. So we did this experiment and we got, out of the 20 trials, 3 successes. So we're asked to state our conclusion in this hypothesis test. So we've kind of got two options for our conclusion. Either x is in the critical region, or x is not in the critical region. If x is in the critical region, then we're going to do what's called reject h0. So what we mean by reject h0 is if we're in the critical region, we're going to say we don't think the probability is equal to a third, we actually think the probability is less than a third. So reject h0 literally means we're going to say h0 is not true and we think h1 is true. So you're going to get a mark for saying reject h0, and then you'll get a mark for making your conclusion. Now your conclusion is always related to the alternative hypothesis. So we're going to say there is evidence to suggest, and then the evidence is to suggest that p is actually less than a third. If X is not in the critical region, we're going to do what's called not reject H0. We're not going to reject H0. So if we do not reject H0, what we're saying is actually we didn't find enough evidence to support H1. So all we're going to do is we're going to say there is not enough evidence to suggest P is less than a third. And notice that both of these are related to the alternative hypothesis. It's either is there enough evidence to support H1 or is there not enough evidence to support H1. So in our case, our critical region is X is less than or equal to 2. So that means that if we have X is equal to 0, 1 or 2, then we would reject H0. Otherwise, we would not reject H0. So we saw X equals 3, which is not in the critical region. Basically, X wasn't small enough. So because it's not in the critical region, we're going to say do not reject H0. And we're going to say there's not enough evidence to suggest P is less than a third.